Hi folks, this is Calc 2 Take Home 4. We're asked to perform this integral, to find this integral using a trigonometric substitution. So if we're doing trigonometric substitution, we zero in on what's happening inside this radical, x squared plus 1, and we think to our trig identities. Which trig identity has a something squared plus 1 equal to something else squared, and that's tangent. We're going to let x be tangent theta, so that the dx is secant squared theta d theta, and need to transform everything. Everywhere I see an x, substitute tangent, and dx secant squared. So I'm going to get the integral of tangent theta cubed times the square root of tangent theta squared plus 1, and that's secant squared theta d theta. This is tangent cubed theta. Tangent squared plus 1 is secant squared. And I have another secant squared out there, d theta. The square root of secant squared is technically the absolute value of secant. Okay, and so now it becomes important when we make this substitution. Where are we making this substitution? X equals tangent of theta. The theta we're doing is in quadrants 1 and 2. It's between negative pi over 2 and pi over 2. That lets us drop the absolute values. I get tangent cubed theta, secant cubed theta, d theta. And so we ask ourselves, can we spare a secant squared and convert everything into tangents? If I keep a secant squared aside, I'd have tangent cubed secant, so that's not going to work. So I ask, can I keep a secant tangent back and convert everything into secants? And this will work. Let me pull the secant tangent back. If I pull the secant tangent back, I'm going to be left with a tangent squared theta times a secant squared theta. And sure enough, I can convert the tangent squared into secant squared. This is secant squared minus 1. Okay, so the next phase is going to take this, make a u substitution, let u equal secant, and that's going to change this into a polynomial. Okay, so here's the integral as we've done it now. We've transformed it into a trigonometric integral. We're going to let u equal the secant of theta. So the du then is secant of theta, tangent of theta, d theta. And so this becomes u squared minus 1. This becomes u squared. And this entire thing is my du. I multiply through there, u to the 4th minus u squared du. And I get 1/5 u to the 5th minus 1/3 u cubed plus c. You've solved it for you, now you got to solve it for me. So we're going to put the secants back in. But we're still not done, because ultimately we need to figure out this in terms of x. So we go back to what our x was. X was the tangent of theta, and we need secant of theta. Okay, so I know that secant squared theta is 1 plus tangent squared theta. So secant squared theta is 1 plus x squared. That means that secant of theta is plus or minus the square root of 1 plus x squared. But once again, think of where theta lives. The substitution for theta is between minus pi over 2 and pi over 2. That means we're going to just pick that one. And so the secant of theta is the square root of 1 plus x squared. So what's our grand final answer to this integral? 1/5 secant to the 5th minus 1/3 secant cubed. It's 1/5 times the square root of 1 plus x squared to the 5th minus 1/3 times the square root of 1 plus x squared cubed plus c. You may want to write that as 1/5 times x squared plus 1 to the 5 halves minus 1/3 x squared plus 1 to the 3 halves plus c. And that'll do it for take home 4.